Hello everybody, how's everybody doing? Hope you're doing fine. I'm drinking my mate here. Uh, we have an exciting day. We have again Mr. Jim Al-Khalili as a guest today, guest of honor. But we'll start with the fan mail. So let me start with that. We have first fella here who wrote a comment and it says, "Gold is money as it can be printed and very hard to dig up, but granite is not." Yes, I will accept gold. My God. Well, the issue here is the context. You will not accept gold if all it does is just take you to the bottom of the sea faster. Okay? Gold is a rock. That's all it is. It has value today. Today, okay, under our economy, under our notions of today. Once the global economy collapses and trade is no more, then gold will be just a rock. Diamond will be just a rock. Platinum will be just a rock. Okay, all those noble gold medals, they'll turn into fool's gold. Okay, so yeah, we're talking about a context here. Context is important. Another question along the same lines. Fella asks, he says, who the first Disneyland economist was? Okay, so essentially I'm going to answer both of them. Okay, first guy and second guy. And here's the rundown. Let me put it over here. Okay. And what we have to understand is what the context is, what I referred to when I'm saying Disneyland economist, okay, or Disneyland economics. Disneyland economics or economy, trade. Any person using the word trade or value, the word value, a dangerous word, value, they're talking about nonsense. Okay, they're talking about Disneyland economics. That only has importance today. Okay, because today is a world of trade. 80+% of our economy is services. What is services? Trade, just pure trade. Even manufacturing to a great extent is trade, and so is food. We don't pay too much attention to those because food is only like in advanced nations, it's only about 1 or 2% of the economy, GDP, and very few workers. Again, only like 1 or 2% in advanced nations work in agriculture. Everything's mechanized, so we produce all the food we want today. Once money is no more, nobody produces food, has no incentive to do so because there will be no trade. What is the natural economy? Food. And food, you don't trade. Hunter-gatherers, especially basal hunter-gatherers, they didn't trade food. I cannot imagine a Neanderthal killing a mammoth and going out there and trading skin for meat or something along those lines. No such monster. Never happened, never will. And when we end up in the asphalt jungle, when money is no more, trade is no more, and the only thing of value is food, you will not be trading food, and neither will your neighbor. Anyone who goes into trade will trade his life for whatever food's out there, okay? So getting back to the first guy, gold only has value in the Disneyland economy, okay? Gold will morph into fool's gold when the Disneyland economy suddenly morphs into the natural economy, and food is the only thing of value. Nobody will trade gold or anything else, a car or a stereo or whatever for food. When food is the only thing that keeps you alive, food is the only thing of value. Value. Okay, you trade surplus, and there is no surplus in the natural economy. Lions, hyenas, they all fight for whatever's there. If there's a dead animal, hey, they'll kill each other for that piece of meat. They won't go out there and hunt. It's easier to fight the other guy, chase him away, especially if you got the numbers, and eat it yourself. So yeah, there won't be any trade. You can only trade food in the natural economy, but no one does. Okay, it's the scarcest of resources, especially animals know animals in the wild. They know how scarce food is. They live day to day, or however often they eat. That's their period. Alligators or crocodiles, they can last a long time without eating. So do snakes, but mammals, they have a shorter cycle, and other animals are even shorter. Unlike all others, food is a vital resource. Okay, hunter-gatherers don't trade food, especially if they are in a subsistence regime. And in the asphalt jungle, the only thing of value is food. So when the global economy collapses, and I did say when, not if, when it collapses, food will be the only thing of value, and nobody will be producing food. Partly because you got to take care of defense. You can't go out there and plant food for whom? For the marauders, the gangs that come around and steal your food, your land, whatever you planted. No, no, nobody will be planting. You'll be too busy eating and defending yourself. And so there's no time for food planting, assuming you knew how to plant, because that's the other issue. Most people are city boys and city girls today. Nobody knows how to plant anything. I thought it was easy. I've been doing planting for a little over 10 years, and believe me, it's it's not as simple as I thought. There is a little bit of science behind that. Okay, another comment. Fellow says, I do think genetics plays a big part, but can't help thinking we are adding to it. Okay, and it's not just autism, it's cancer, CPOD. It seems we are not evolving anymore, but mutating. Yeah, the issue is that we don't mutate. I mean, we are mutating now more not because of any of this. In fact, there was another question along those same line. Maybe I should put that up there. Fellow says, what exactly affects the genes? Could it be mercury in the vaccines and in the environment that affects the genes? I don't think it's got to do much with environmental issues. I think all this mutation that we're having today deleterious, because a lot of people are having not only physical but mental problems that have an origin in genetics, right? Especially the most extreme cases. I think it's because we've been inbreeding for hundreds of thousands of years. We haven't had any new blood, and I think it happens to all species towards the end of their life of the species, where they whittled out all their genetic diversity. In fact, if you look at a lot of these animals that they've analyzed, like the Tasmanian tiger, one of them comes to mind, another with a passenger pigeon, and I'm sure if we would have done the dodo bird, in fact, they may have done a dodo bird in retrospect, I don't know if they did, but all these animals ended up with very little genetic diversity. And this gives you an idea that those animals were about to become extinct no matter what. We blame it on humans. We say we hunted the passenger pigeon down, the great auk in near the Arctic, Iceland or Greenland, and a Tasmanian tiger. No, I think those animals were already about to go extinct. We just finished them off. Especially the passenger pigeon. There were millions of them, and that gives you an idea that they're at the end of the line. It means that they grew old, they grew big. There's some markers that I pointed out to determine when a species is old, and I'm saying the passenger pigeon matched almost all of them. They were a large type of bird, old, numerous, and probably had very few children towards the end. I don't know about that, but some of the characteristics are there. And we just finished them off, but they were on their way out anyways, from a genetic point of view. And I think it's because of inbreeding after so many centuries. That's one issue. The other issue here, I've put a couple of things there for people to see. Was it this one? Yeah, towards the end of a species' life, there is little to no evolution. By then, genetic diversity has practically disappeared. A species is young when it's still colonizing new environments and adapting to new diseases, predators, prey, vegetation, climate, etc. Right? Births and deaths are high. When a species is young, you have high births and high death rates. And when it's old, it has very low um, births and lots of deaths at the end, right? Because deaths surpass the birth at the end. And that's when the cycle goes down. When a species settles down and becomes sedentary, more of its members get used to endemic diseases and live longer. Okay, and the population pyramid begins to overturn on that species, and that happens to plants as well. You know, the redwoods in California, they're old. They've been around. They're sedentary, you know, in the sense that they're not migrating across the planet like other plants. There's a lot of they're resistant even to fire. So they've been around for a while. It's an old species and it's dying. So you don't have to kill the redwoods. It's on its way out. And by on their way out, I don't mean it's going to die tomorrow. It's probably going to take a few thousand years after we're gone. Okay. But the redwoods, you know, for a species that's lived millions of years, a few thousand years is nothing. They're on their way out. That's my take on that. And here's the chart that I've always used. That's the graph for any species whatsoever. Okay, I think if you look at the charts that they have out there, they stop at where you see you are here, and they say, "Oh, it's the S curve." They never finish the S curve, and so I finished the S curve for them. That last stretch there, which is very exponential downwards, it leads to extinction. And this is essentially the curve for our species, where you see the little arrow there, that's where we're at now, and that's how far we've got to go. I don't think we have too much to go. Our species will go down very fast, I think. And, you know, the only difference between a species that dies in a background extinction, other than this one, which shows more the pattern of a mass extinction, is that curve up there at the right is just a little wider. Okay, so it takes a little longer for them to die, which I think is what happened to the Neanderthals. The Neanderthals were already on their way out. You can see that in a couple parameters, and I mentioned those the other day. One is that they had lost their genetic diversity, and we have a couple data points. We don't have too many, but we have a couple data points. One is from about 80,000 years ago, and the other one from about 40,000 years ago. And they've already noticed through genetic analysis that the Neanderthals had lost genetic diversity during those 40,000 years. The other one is a study that I mentioned, that there was a 2-for-1. By the end of the Neanderthals' life, the species, there were 2 older adults for every young one. And that wasn't the case, you know, in previous thousands of years. So those 2 things give me an idea that the population pyramid overturned and that they lost their genetic diversity. Anyways, those are the ones that I propose for a background extinction. That's my take on it. It's up to you to look into it on your own. I'm just urging you to take those into consideration when you look at extinction. Okay? Background extinction. Anyways, moving on, here we have a couple issues regarding God. Good old God. He's always around. I have to take exception when your finger and being able to move God just because you move your finger, which I did the other day. I was moving my finger up and down and moving God. In relation to something doesn't mean the other thing moved. Yes, it does. And the way we do this in science is we define words, we define our terms, okay? And so here's a definition. We have these definitions are necessary to talk about motion, okay? One is that you have to define what an object is first, because only objects can move. So we have to say that an object is that which has shape, not that which you can touch or see. Then we have to define distance, separation between 2 objects. Location is the set of distances from one object to all the rest in the universe, okay? Motion, two or more locations. And so let's put our finger in motion and begin moving God here, okay? So let's, give me a second here. There he goes. How's that? I move my finger, okay? And every atom in God's body, if he's an object, right? And you can make him of a single piece. I don't care. If you want to do that, that's fine with me as well. But God had better have shape. Otherwise, we can't even talk about existence or about motion. We don't move concepts. So God had better be an object. If God is an object, okay, and I'm just going to use this, I'm going to say that he's made out of atoms. Well, every atom in his body is moving with respect to my little finger. Okay, the distance is changing, therefore his location is changing with respect to my finger. So God can stand absolutely still and he's moving, he's changing his distance with respect to the tip of my finger. Okay, so his head is changing with respect to my finger. His hand, his legs, every piece of his body is changing distance, location with respect to the tip of my finger. So yes, God moves because I could just as well assume that it's the finger that's standing still, okay? And God is moving back and forth, up and down with respect to the tip of my finger, okay? So motion requires two objects. In other words, a relation between two objects, or because if you're gonna talk about location, you need at least two objects because you need two objects for distance. Okay, so motion requires two objects, and it's a relation between these two objects. And if my finger moves with respect to God, God is moving with respect to my finger. You can't avoid that. Not under these definitions. You don't like my definitions? Very simple. You got to start with definitions so we know what you're talking about. Otherwise, you have no case. Not in science. Maybe in religion you do, but we don't care about that. Here we do science. Another issue regarding to God, fellow raised here, and he says, isn't more important a definition of God than a definition of the word exist? If we try to understand whether God exists or not, we should first define what God could be. If God exists, he is infinite, therefore he cannot be an object. Aha. Well, okay, if God is infinite, I agree with you, he's not an object, okay? So, but we got to find out what the word infinite means, and we've discussed this in the past. The word infinite is an irrational term when you bring it into science. In ordinary speech, in mathematics, in religion, we don't care what the word infinite means because it has, it's an undefined term and people use it liberally, so we don't care what it means out there. In science, the word infinite is an irrational term. The word infinite is an adjective. An adjective in science, in physics, qualifies an object, okay? So when you say that God is infinite, what you're saying is that God is an infinite object. And that's a contradiction, okay? Because all objects are finite. All objects have shape because that's the definition of objects. So there is no such thing as an infinite finite, okay? That's an oxymoron. So that's the first issue. But we have more in there. The question is, you have to, let me put this up here. You have to define God, yeah. So if God has only two choices, every word in the dictionary has only two choices. Either God is, let me take this fella out of here. What is it? This one? Yeah. God is either a concept, which is the group on the left, or God is an object, the fellow on the right. Either God has shape, or God is any of these concepts or any others that you can think about. Love, intelligence, spirit, or energy. Okay, those are the words typically used for God the concept. If God is any of those words, he doesn't exist by definition. We can't even talk about motion because all those are abstract concepts. If God is an object, that's different. Then he's the guy on the right. Creator is a good name for him, synonym for him. He looks like a human. Okay, fine. And now we can talk about God existing and about God moving. Okay, so or anything, for that matter. And so if we're going to talk about existing, yes, now that we define God as a thing, as an object, as a entity, medium, whatever you want to call it, anything, nothing, something. All these words mean the same thing. That means that which has shape. So God had better have shape. Otherwise, we can't even talk about his existence. Now we've defined God, or we point to God and say, that's God there. Okay, we point to with our fingers, there's something with shape there. Now we can move on and talk about whether God exists. And here it is. Here's the definition of exist. Physical presence. Physical presence requires an object. What is an object? That which has shape. If God wants to exist, in addition, he needs to have location, set of distances to all the objects in the universe. Okay? And no, we don't determine God through the senses. The way we determine whether God exists or not is through definitions. We have to define the word exist, and then God either meets the definition, the criteria, the specification, and exists, or he doesn't. It's just that simple. Okay? So, the way we do it is with definitions. So it's objective. There's no, I believe in God. That's too subjective. We can't use that in science. I believe in this chair. I believe in Mighty Mouse. I believe in Superman. No. I don't care if you believe or not. In science, we have to define what the word exists. And in order to have the word exist be used consistently, rationally, scientifically, it has to be applied only to objects. What is an object? That which has shape. If you don't like those definitions, very simple. Provide your definitions, get in the ring, fight for them, and we'll see how it goes. Okay, next comment. We're getting now a little bit into physics here. Okay? And here it is. Everything's moving, nothing is static. Is that not so? Yeah, it is so. Everything in the universe moves. Okay? Motion is perpetual as far as I'm concerned. Okay? And like I said once, it's perpetual motion. Why? The universe is the only perpetual machine. Okay, or thing, or whatever you want to call that, the universe. Why? Because it's composed of two components. It's got two components. One is matter, and the other one we call space, which is nothing. But we treat it momentarily as an object to define the word universe, which is a concept. So the things, the atoms, are always in motion, and they have no way of getting out of space, because space does not have borders, does not have a boundary, does not have a fence you can cross to the other side of space, whatever's out there. No, and space is not infinite, because only objects can be infinite, and that would be a contradiction with the word shape, which is finite, right? All objects are finite, so we can't have an infinite object. So space is not an object, so we can't even use the word infinite, the adjective infinite, to refer to space. That's the first thing. Second one is that space has no borders. That means space is nothing. Space is vacuum. All these words are synonyms. Zip, zero, nothing. Okay? Nothingness. So the matter in the universe is constantly moving, and it has no way of either converting into space or escaping space, because space has no borders to cross. Not even God can escape space. Okay, so the issue here is that everything is moving, but that isn't the point. The point here is that when you are talking about physics, this is the context that you need to get under your belt. Okay, let me get it up here. Okay, that's an object, because it's the only object in the universe, and that's how we present objects in physics. We point and we give it a name. And so we say that's a blob, or that's an A, that's a Z, whatever word you want to use to define that shape that you see in front of you. Okay? So that's the way you present an object in physics. Okay? And it has to be the only object in the universe, and it can't be in motion. Does that mean that somehow we have that some objects in the universe are not in motion? No, it means that for the purposes of physics, this is the way you present an object. It has to be the only object in the universe. You remove all other matter, and you point and you say horse, or you say tree, or you say rock, That's how you present an object in physics. That doesn't mean it's not going to move or that it isn't moving. We're not there yet. That's part of the theory. Right now we're talking about presenting the objects to the crowd so that they understand what the objects are. We have to point and name. That's it. That's how you present an object in physics. So if you want to present God, for example, yeah, you can present God. You got to point and name. Say, that's God. And if you point to nothing, well, God is nothing. And then he cannot exist because nothing is a concept. So hopefully God has an object if you're going to point to God. And if you don't like to point to God because that diminishes his power in your eyes and that destroys your religion, all you got to do is define God as either an object or a concept. If you define God as a concept, you can only point to an object. But if you define God as an object, by definition, God does not exist because no concept exists, not in physics. In ordinary speech, yes. In physics, it has to have shape in order to exist and location. I hope that's clear. Okay, we're talking about rational speech here, talking rationally to another human being, and so we have to use these words very carefully in physics because that's 99% of how we got into the nonsense of relativity and quantum mechanics and string theory, because they never defined their terminology, because the mathematicians don't care about terminology. They only care about numbers, equations, and other nonsense that has nothing to do with science, measurement, experiments, all that nonsense. Okay, another question. How does the push force work in the rope world? Okay, let me show it to you first. Let's see if I can take this out, so make it simpler so you can see more. Okay, here's my rope. Okay, if you torque a rope, you know, and here's the atom at the other end, I'm going to torque it. Well, I already feel a little thump there. I mean, at 300,000 kilometers per second of that torsion moving along the rope or propagating along the rope, you would feel a little thump there, okay? And every atom is receiving that thump. So the rope torques, and it already, since it's part of the electron shell that forms the other atom, it twists there. It gives you a little twist there. And that little twist is a little thump, a little pressure point, okay? So that's one way in which the rope model pushes. Let me give you a couple more. Because there's nothing wrong with atoms pushing on atoms, okay? So here we have two hydrogen atoms converting into the hydrogen molecule, hydrogen gas, okay? And so what they're doing is they're pushing on each other in a sense, right? And they merge and they form the hydrogen molecule, okay? The hydrogen gas. And then just in case, I'll give you one more, and it's this one here. And that's the repulsion of two magnets. You can see that the threads spin around and they push, the magnets push each other away. Okay, so that's the mechanism we're proposing. It's not ropes, it's threads, but the threads can push on each other if they come in gazillions of threads from both magnets. Okay, so it's not like push is outlawed with the rope model. You have atoms pushing on atoms. You have rope pushing on the electron shell. And you have threads pushing on threads when two magnets push each other away, repel. Okay, so those are the push mechanisms under the rope model. Maybe there's another one or a couple more. Those are the first ones that came to mind. Okay. Okay, another issue raised by a gentleman, and he's got a lot of questions here. He says, why is hydrogen stable even when stretched out into deuterium, but then suddenly quite unstable when stretched out into tritium? What makes uranium-232 4 orders of magnitude more unstable than the tensor uranium-234, etc., etc.? There must be a rope explanation for the well-known alpha decay, okay? Is there yet any interpretation in the rope hypothesis for the phenomenon of positrons, okay, and neutrinos? Are those just nonsense? Well, the last one I can answer real easy. Yeah, neutrinos are nonsense, okay? They're just effects that people observe the visible stuff and simulate them really with computers because they don't even observe them or anything. It just happens so fast, so quickly. They do all this with computers. They simulate them, and they always put particles in there. And that's how they came up with a neutrino. So no, there's no such thing as a neutrino if there are no such things as particles anywhere in the universe, discrete particles. And that's the challenge we give quantum. Quantum cannot explain any invisible phenomenon of nature with particles, with their particle hypothesis. And since string theory is also based on particles, in other words, it's a quantum theory that just says that the particles are vibrations of 1D strings, then that means string theory dies as well together with quantum mechanics. Now, general relativity is also a particle theory. Okay, I want to make sure that people understand that all of mathematical physics in the last 10,000 years has been particles. Even waves are particles. What's a wave? The vibration of the ether, the vibration of particles. What's the ether? Bunch of particles. What's space-time? Bunch of particles. What's the quantum vacuum? It's a bunch of particles. They're all the same thing. They're talking about particles. When they try to prove general relativity, what was it? The photon was treated as a discrete particle swerving across warp space, and that's how they proved the warpage of space-time. So it all comes down to particles. Okay, we're saying something different. We're saying that all atoms are interconnected. There's a physical entity between any two atoms, and the only issue there that people raise, really, that's the only issue is touch and see. Why can't we see them? Why can't we touch them? Why don't they tangle? It's all touch, see, and people can't understand that. They have big stumbling block there, a big barrier doesn't let them understand. And no, Mother Nature fortunately made the ropes that interconnect every atom. They're elongated, right? Made them invisible and intangible. Because if she would have made them either visible or tangible, that's all we would see, and we would be tangled in knots. So the mediators that Mother Nature uses to do her invisible workings are invisible and intangible, and people have to come to terms with that. You know, that's why we have never discovered how this universe works, and we never will until we accept something between atoms. Right now, people say, no, we're shooting little balls, but you can't produce pull with that. And the only way they can do that is, turn it around and say, well, the objects are being pushed from behind by particles. We take the particles from between them and the others push them from behind. So they talk about pressure. It's always push. And here we're turning it around and saying, no, there is a force of pull in nature. And it's just that we can't see that mediator and can't touch it. And once we get over that barrier, it's a piece of cake, because now we can explain a lot of stuff out there. Now, this fellow is asking a lot of questions. And first thing I want to say that, the first line of attack is to get the basic theory out there. And that's already a monster. I've written a book lately, and I think it was April, which I made free to the world. Everybody can see it, and it gives you an introduction to the rope model. And specifically what I try to cover there, okay, is this. Let me put this up here. The invisible stuff, okay? I want to primarily cover light. What is light? It's a torsion of a rope that we can't see or touch. The workings of the atom over there on the right. Then we have electricity, which is the bottom left. And the bottom right is magnetism. We have both. We can explain with a rope both attraction and repulsion. It's the threads that swing around. And we also try to answer this, gravity. And you can see how gravity works under the rope model. It just, as the object approaches, there are more independent ropes intervening between two objects. And you can see there just a quick snapshot of what's the difference between an object which is far away and one which is closer by. Weight, which is the measure of gravity, weight is location specific. Okay, so we can explain these invisible phenomena. That's already a monster to try to get that to people. And then, you have people like this fellow, and he comes in, he asks quite a few questions, and they're important questions, and we We absolutely like them. Now we have a group in Facebook, the Rational Science Group, and we discuss such issues. We bring them up and we try to explain them as best as we can. Remember, the theory is in its infancy. Okay, we're trying to get the basics out there. That's already a problem. And some problems we have tried to figure out. And I think to some degree I've tried to answer them. Here's one of them. Okay, and which is one of the first question that this fellow asked, and that's how hydrogen turns into deuterium. It just captures a neutron, and then when it captures another neutron, now we have tritium. But tritium is unstable, it's radioactive, and it just, why? Because the shell is expanded to the maximum, the hydrogen shell, and so it tries to get rid of that neutron and turn back into deuterium. This is our explanation, my explanation. Some folks out there in the rational science group, they do not accept that there are free neutrons. They have a different explanation. I know one of them, Monkey Mind, I think he doesn't accept or has a different explanation for free neutrons. Okay, but here this is my take on this. Okay, so we're trying to get explanations for all these phenomena. Okay, now if the rope model ever gets off the ground, and again, I don't know how that can happen in such short time that we have here on Earth, as far as I'm concerned. One of the places where there's going to be a revolution or where there's got to be a lot of work is in chemistry, to some degree. You could also argue that what you have is if you look up the word orbitron on Google, you'll find all these models of the SPD levels, and that's essentially the rope model. That is the rope model. They've been using it in chemistry for years, okay? And we have no problem with that because that is Schrodinger's equation applied to the rope model, essentially. So we have no problem with the orbitron model that you'll find on the internet. But there's going to be some revolution in ionization and electricity because we have a different model altogether for what those are. We have a different model for what magnetism is. And those concern quantum mechanics because quantum has to answer those issues because those are here on Earth. You cannot answer magnetism by saying, oh, just go to classical mechanics. No way. That's a quantum. If quantum replaced classical mechanics, quantum mechanics has to have an answer for magnetism, and today they have an irrational, idiotic answer, which is that the electrons spin. So what? If the electron is a little ball that spins in one magnet and spins in the other, that still doesn't explain how one electron affects the other from a distance. That's magic. Okay, so again, they have no solution to magnetism as well. They don't know what electricity is. They don't know what ionization is because they say the electron left the atom. Well, what kept it faithful to the nucleus in the first place? Why didn't it spontaneously jump out? Why did you have to stimulate it into ionization? And so none of these questions have answer under quantum mechanics. So quantum mechanics is nonsense because they have no explanation for any invisible phenomenon, whereas we do. We have an explanation for each one of those. Okay, so when we compare the rope against quantum stands no chance whatsoever. The only advantage quantum has is that it's been around for 100 years and everybody believes it. Other than that, it has no support, no justification whatsoever because it's all irrational. And just the fact that quantum mechanics says that a particle can be at two places at once already gives you an idea that these people have no clue whatsoever. And what they do is dismiss all that as philosophy and say, well, that's not science, that's not physics. Physics is math, and physics is measurement, and physics is equations. Physics is predictions also, and physics is not explanations of mechanism. And they dismiss that as philosophy. And so that's where the problem is. We have to show that science is not description, is not math, is not experiment, it's not prediction and none of that nonsense that we've been doing for the last 400, 500 years. No, science is explanation. Physics is explanation of a mechanism. And which mechanisms? Well, all the visible ones we can answer. We know how a pulley works. We know how a seesaw works. We know when we throw a ball, we can not only explain but describe every little piece of it. Where the mathematicians die completely is when they have to explain the invisible phenomena, gravity, light, magnetism, electricity, the workings of the atom, that sort of thing. That's where they run into trouble because they can't see, and the only way are going to see is by visualizing. Not by seeing with your eyes or touching with your hands, but by visualizing how Mother Nature is doing that mechanism. Then you will see. Then you will see with the mind, not with your hands or your eyes. Okay, so that's where we stand. Anyways, nothing prevents this fellow from applying the rope model to his questions. Okay, and that's important too because I'm a one-man band and I'm trying to get the basics out there. That's my priority. It's been for quite a while, and so I really have little time to go into all these little details. And other people are doing some of that, out there. And if you're interested in figuring that out, well, just apply the rope model to your questions. How would you apply it? I mean, do you need an answer for everything? Do you just memorize, go to school and say, well, this is what my teacher taught me and this is what I'm going to memorize? Or should you break your head and try to figure out the puzzle yourself? So those questions that you ask are important. I'm not saying they're not, but, help us out. If you know a little bit of chemistry, apply apply the rope model to what your expertise, your line of expertise. Nothing stops you. We can't solve all your problems, and some of them we have not solved because we don't even know what the questions are. In many cases, when the question comes in, we say, "Oh, we never talked about that." It's kind of like that. We haven't covered all the bases because we don't even know all the bases out there. All we can tell you is what the basics are, the introduction to the theory, and how you can apply it in the most obvious cases, light, gravity, magnetism, etc. Again, nothing stops you from telling us how the rope can be applied to those questions. Okay, and I'm sorry I don't have a better answer than that for you. Okay, let me talk about something which bothered me the other day, and that's my explanation that I gave for this phenomenon, which is the Bloch Wall. Okay, and I wasn't satisfied with my answer, and so I'm going to revise that. Okay. And the revision doesn't really have a good answer either, so don't hold your breath, okay? I'm just going to tell you what the problem is here. And here you have two magnets, north and south, and you can see those lines in there. What's the issue? The issue is that this Bloch wall, that was a question that was raised the other day, goes east-west with respect to the north-south magnet, okay? And we have to try to answer this under the rope model, okay? So I'm not satisfied with the answer I gave the other day. I think there are problems with it. And I'm trying to break my head. Again, I do this part-time, try to figure out some of these problems. And one thing I looked at when analyzing it this week, just quickly, briefly, okay, is that you can see those lines in the center where I drew the circles, the red circles. You can see those are closed loops. There are circles there. That means that the threads coming out of the south end, out of the north end and coming into the south end, which is the way a magnet works, the threads would sweep around and come in the south end. You can see those in the center. They do not make the full loop. So they're not going all completely around, coming out of the north and entering the south. They have much shorter radiuses. Okay, they go right through the middle of the magnet, and the closer you get to the center between north and south, the more circles you see. So they're like concentric circles. And obviously, I have to revise my notion of magnetism here. Okay, it's an interesting problem, and so I'm confessing that, yeah, this is a problem and we need to resolve this. Okay, so here's homework for some of you people. There I drew, okay, the Bloch Wall goes east-west in this case versus the north-south directions of the magnet. But you can see that if we superimpose these circles in there, and they could be two circles, for example, the one on the left, maybe the threads are sweeping around that Bloch Wall, and that's why you have that straight line there, because the threads are meeting right there in the center of the magnet. The one on the right shows circular patterns right in the center. So again, it shows that the threads are not coming out of north and going into the south, not all of them at least. And so this is one thing that we do have to answer. This is a problem we need to solve, okay, for all those rational scientists out there. Okay, this is where you need to put your heads together and find out how you explain that. And when you look at a spherical magnet, you see something similar. Okay, you see I drew those two blue circles on the both magnets, on the one on the left, on the one on the right. And you can see those lines don't go completely around and come in through the north. No, they go in circles locally between the north and south interface. Okay. In fact, you'll see that also with a magnetization of the Earth. And this is where I got a little confused in the past, because if you look at the Earth on the left, you'll see that the arrow, the shortest arrow, the smallest arrow there, the one closest to the Earth, it goes around the Earth. And so you look at that and say, okay, yeah, all the threads go through the north, through the south, and come out the north, because remember the Earth is turned around as far as south and north polarity. But you see the one on the right, and that shows a different picture, and that's the one I think we have to answer, because that's the correct one. And you see I drew a circle around that little arrow there, and that one doesn't go in through the North Pole, known as the South Pole. No, that goes locally. Okay, so if the Earth is divided into north and south, and somehow if we cut the Earth in half, we would find the Bloch Wall right there where you see the equator, or close to the equator. You can see those circular lines there, and I think they represent how the threads are swinging in that region. Okay, and so I'm still studying this problem. All I can tell you is that one, I'm not satisfied with the answer I gave the other day. I am researching that again part-time whenever I can get to it, but it's an interesting problem, and I think what's happening there is you have swinging of threads also between north and south in the center of the magnet. The closer you get there, the more tinier circles you have of the threads, and where they meet, that forms the wall, which is called the Bloch Wall. That's my intuition right now. Okay, if someone else wants to tackle it, go ahead. Be glad to hear from you on that issue. Okay, let's get to the man today. We have Mr. Jim Al-Khalili, okay, and he's going to be our guest today, guest of honor again. And I do think of him as a caricature of a physicist, and this is what I'm going to cover right now. So these are essentially, I'm going to start with the objections so that you can see later on how I cover each one of these points. First one is that he states that gravity is the central to his line of work. So he's more or less an expert. He's a PhD out of university in England. And so he says that gravity is what he studies, or it's important to his line of work. So we got the right guy here. We have a mathematical physicist who studies gravity. Okay, good. We got the right guy. And so welcome to our group, to our chat, Mr. Al-Khalili. We'll speak for you, or have you speak through us. Okay. The first problem, he can't define mass. He doesn't know what mass is. And even though mass is central to gravity, black holes, dark matter, all that stuff that the mathematicians invented. So he doesn't know what mass is. He tries to define it, but we'll find out that other people object to his definition. And it's not me, okay? Gravitational time dilation is debunked with 2 hourglasses. I'm going to show that today. Doesn't understand the difference between describe and explain. Okay, math describes, physics explains, so we have a difference there. And he doesn't understand. He goes back and forth between describe and explain, especially when he deals with Newton. I'm going to cover that. Claims without justification that there is no object. He gives the example of a string between the earth and the sun. And no justification for that. Yes, there is an object, just that we can't see or touch it. That's it. Makes a rational proposal that matter warps time. No such object as time, so you can't turn it into a banana and say, oh, time is warped. Asserts that a telescope proved that matter warps space. I don't know how a telescope proved that if space is not a physical object. And then he says that time is not money. Time is gravity. Time is gravity. Okay, so that's what I'm going to cover now. Okay, so there's the rundown. I'll return to that at the end of the lecture. Okay, so here it goes. Okay, first one, he says that gravity is part of it, central to his work. And in exploring it, I'll be challenged in how I understand this most mysterious force. Turns out he talks about the mysterious force, then he says he knows what it is, then he says it's still a mysterious force. We don't know what it is. So does he know or doesn't he know? And well, you will never find out from him, because he goes back and forth saying, oh, we know what it is. Like he's going to conclude that time is gravity, and then he says we don't know what it is. Partly because they don't know what time is, partly because they haven't defined the word time, so that's goes on and on and on and on. Okay, gravity's many mysteries are all contained in this single action, how an object falls. And what he does, he drops, I think a rock first, or an apple. I think he dropped an apple, okay? And into the water, and he says, this is what it's all about. And he's totally right. The only experiment you ever had to do, I'm going to do it with a rock, okay? Here it is. This is the only experiment, repeatable experiment you ever had to do regarding gravity in your life in the last 500 years. You let go of the rock, and it falls all the way to the floor. That's it. That's the experiment. What do you want to do 500 more experiments? You want to do it a million times to make sure that the rock falls to the floor? Yes, it will fall to the floor. You do it once, you're finished. You never do an experiment on gravity again. Now the issue is explaining how Mother Nature does that. You're not going to explain it with math, because math can only describe. You can only explain it with objects. Something invisible and intangible to us comes in contact with every atom of the stone. And that's what Newton's equation more or less describes. Okay, he never explained it, but he described it like that. Okay, here's our first encounter with Mr. Al-Khalili or Jim. Okay, for those who are friends with him like me. Okay, he tries to define the word mass. He says mass is often confused with a related quantity, weight. Confused? They're the same. They're synonyms. Weight and mass are synonym, perfect synonym. There's no difference between mass and weight. So whatever they taught you in high school, in college, if they taught you that they're different, they lied. Because the way we determine mass is through weight, and they've never been able to separate that. But let's continue. The mass of these dumbbells, he had 2 dumbbells there, I think he was one of them, is fixed. Okay, it doesn't change. It's a measure of how much stuff they contain. Absolutely not. It's not a measure of how much stuff they contain. That's not what mass is, because we measure mass through weight. We weigh it. We put it on a scale. That's one way. There's another way, but primarily that's the one. And anyways, we have here 2 gurus, and I've mentioned these guys before. Nature does not offer us any concept as the amount of matter, which is what Khalili is referring to. History has struck down every proposal to define such a term. Even if we could count number of atoms or by any other counting method try to evaluate amount of matter, that number would not equal mass. Okay, that's my first piece of evidence to show that this fellow doesn't have any idea what he's talking about. Here we have the Wikipedia, just to rub it in. Mass is not the same as weight, okay? Then what is it? Even though mass is determined by measuring the object's weight. Yeah, that's how they measure it. So that's why we have no difference between mass and weight. We don't count atoms to determine mass. What we do is we weigh it. Second point there, in physical science, one may distinguish conceptually between at least 7 different aspects of mass, or 7 physical notions that involve the concept mass. So these people have no idea what mass is. They've never defined the term. They have no idea. They defined it, then they redefined it and defined it once again just in case. So we have 7 notions, and people just use whichever notion comes to their mind, okay, whichever one helps them. Then we have the physics fact, and I like this one because these guys consider themselves gurus. They're experts. They know it all. And they say mass measured in kilograms refers to an intrinsic property of an object. Aha! Whereas weight measures an object's resistance to deviating from its natural course of free fall. The weight of an object equals its mass times the local, okay, acceleration due to gravity. That means it's location specific. That's what a weight is. We don't need to move anything to have weight. Weight means how far you are from an object, which is Newton's equation. This idea of weight is independent of the object's state of motion, of course, and doesn't consider any contact force. Okay, so weight is location specific. Now, when we get to another little article that the physics fact has, it says, when the particle, referring to the photon, right, is at rest, its relativistic mass has a minimum value called the rest mass. No, it doesn't have a minimum value. It has 0, but they weren't willing to say that. Rest mass of the photon is 0. Okay, and these people kind of lie. They try to weasel out and they say it has a minimum value. Okay, what value does it have? What is this rest mass of the photon if it has a minimum value? No, it's 0. But this is the funny part. It says, as the particle is accelerated to ever higher speeds, its relativistic mass increases without limit. So it's not an intrinsic property mass, right, of the photon, because the photon has no mass. But when it moves, which is actually, what we're talking about here is weight, another way of measuring weight. When you move, if you jump on the scale, you'll see that you weigh a lot more. And that's what they're saying. Relativistic mass is mass in motion. And that is not an intrinsic property of the photon or of the thing in question. Okay? They can't say it's an intrinsic property if they say it relates to, has to do with motion. If it has to do with motion, it's got to do with all the stars in the universe, because that's what you're running against, known as Mach's principle. Okay, so they don't have any idea what mass is, and so Al-Khalili is talking out of his, behind. Okay, let's move on here. Jim did a lousy job with mass because he thought it was the quantity of matter. He thought it was an intrinsic property. No, it ain't. Right now, the only way we determine mass is through motion. We either put it on a scale or set it in motion. And in both cases, in one case it's location specific, and that's called weight. So there's no difference between mass and weight. And we don't count atoms, so we don't know how many atoms an object has. So mass is not the quantity of atoms or the quantity of matter or a measure of quantity of matter, because a measure means you're going to move it. And measuring is not counting. People don't understand that, especially mathematicians. They don't understand the difference between measurement and counting. Measure is something, in this case, pertinent to this discussion, is when you move something, okay? So it's got to do with motion. That's what measuring is, because you're going to measure how much something weighs against the scale, okay? You're not counting atoms, which is what the quantity of matter refers to. Nobody counts atoms to determine how much mass you have. The way they do it is they put it on a scale and weigh you. Okay, that's one way of doing it. Okay, next issue, time dilation. Why does gravity change with altitude? He asks. Okay, why? I've got 2 identical clocks here. Now, because the clock lower down is closer to the center of the Earth, it feels ever so slightly a stronger gravitational pull than the clock higher up. Einstein's theory says that the lower clock will tick by at a slightly lower rate than the higher clock. Basically, gravity slows time down. Is this true? Well, let's find out, because this is cornerstone of Einstein's theory of gravity, gravitational time dilation. That's what it's called, okay? Let's find out if what this fellow Al-Khalili, who just memorized stuff in college, is correct, if he's got his facts right, okay? We're going to talk about facts, objective facts here, okay? Here it goes. Yeah, he's got to be surprised, because if we put two hourglasses, the one that is closer to the Earth will tick faster. The grains will fall faster, or at worst, it'll fall at the same as the ones on top. In fact, if I take that hourglass farther and farther away from the Earth, where we still have a little bit of gravity, those grains will fall a lot slower. That means that time will go a lot slower in the upper hourglass than in the lower hourglass. The lower hourglass will clearly pull those grains faster than the one on the top. So the way you measure time dilation, gravitational time dilation, in an objective way is not using an atomic clock, not using what Al-Khalili used, which is an alarm clock. No, what we use is an hourglass, which is a gravitational clock. That's what you use to measure time in relation to gravity, okay? So don't bring your clocks, I'll bring mine, okay? I'll bring my 5-cent clocks, and I'll do the experiment my way, okay? And then prove, I mean, if experiments prove anything, okay, here's an objective experiment that proves that gravitational time dilation from Einstein, a cornerstone of general relativity, is absolute garbage, okay? It can be thrown in the trash can. Okay, and just in case we rub it in, because if the Earth were closer to the Earth, just location we're talking about here, if the Earth were just standing still and closer to the sun, it would weigh more than if it's farther away. Just that simple. Why? Because weight is location specific, and weight is a measure of gravity. And the way we do that in science is say that, you know, all the ropes are connected from the sun are connected to every atom that comprises the Earth. The closer the Earth is to the sun, the more the ropes open up, and that's why the Earth weighs more closer to the Earth. That's why the acceleration of gravity is faster closer to the sun, and why it's less farther away. That's why an astronaut has very little weight out there and floats in space. Why? Because he's so far away that the number of ropes that are converging upon every atom in his body have more or less, you know, turned into a single coaxial. Okay, so he doesn't have that pull that you get as you approach the Earth and the ropes fan out. He doesn't have that. That's why he floats out there in space. Okay, here Al-Khalili shows that he doesn't know the difference between a description and an explanation. Math only describes, so he can't use the word explain anytime he uses the word math or relates in the context of math, okay, equations and whatever. He says, Newton said there is an attractive force between any two objects in the universe. Yeah, okay. Newton's equation uses the word describe, correct. Why an object falls to the ground. An equation can only describe. An equation has no power to explain whatsoever. Nothing out of mathematics can do anything other than describe. It has no power to explain. But then he moves on and he says his law of gravitation can still be used today to explain how orbits work. Oh yeah, how do orbits work? Why doesn't the Earth fly out of the solar system if you can explain the mechanism? What are you going to explain with an equation? And see, this is the issue. Then he says Newton's famous equation also explains the strange effects that objects get lighter as you gain in altitude. Yeah, how does it explain it? Please explain. No, they say, you know, if you're farther away, the equation says that the greater the distance, the less you weigh. That's all, the equation says that, but that's a description. That's not an explanation. This fellow doesn't know the difference. Why? Because he was just a little altar boy that got his PhD by repeating what he was taught by rote. That's it. So he has no idea what the difference between a description and an explanation is. In science, we explain. In physics, we explain. In math, they describe. And so this guy's a mathematician. He's not a physicist. He's just a petty mathematical physicist. Physicist is too big a word. He's just a mathematician. And all he does is describe. He can't explain a single thing, and you'll see that in a minute, as soon as I get there. Okay, so what does Al-Khalili do? Well, he goes in there and he tries to explain gravity, and he says, look, imagine I'm Newton's gravity, okay? Why Newton's, how he interpreted Newton's equation. Imagine I'm the sun and this tennis ball is the earth in orbit around me. Newton's law can describe very precisely the path the earth takes around the sun in terms of the mutual gravitational attraction between the two bodies. He uses the word describe, correct. But what Newton can't explain, yeah, Newton, Einstein, no one in mathematical physics, no mathematician on earth can't explain is what connects them, the sun to the earth. In reality, of course, there is no invisible string between the earth and the sun holding the two together. Yeah, how did he determine it? He just says that? I mean, where did he get that? Sure there is, okay? There's just empty space, a complete void. I think the void is between his two ears. He hasn't justified that statement like no mathematicians in the last 400 years has justified that statement, that there is nothing between two atoms, between the earth and the sun. That it's just empty space, whatever empty space is, because they don't believe in empty space either. They say it's made out of particles, so we don't know what they're talking about when they say empty space. And yet, according to Newton, the earth and the sun pull on each other instantaneously across a vast distance, correct? How can gravity act in this way when there's nothing to connect or transmit it? Well, if there's nothing, you can't explain it. It's only when there is something, then you can explain it. And here's that something, okay? So let's show Mr. Al-Khalili why he was too quick in dismissing that string, that something which he calls nothing. Here it is, okay? So yeah, he might be surprised to learn that every atom on Earth is connected to every atom in the sun, and the sun just simply twirls it around, just like he's showing there on the bottom left. That's how the sun twirls the earth around. Now we can explain gravity, or why the earth doesn't fly out of the solar system. Why? And why it keeps the orbit, because the sun just keeps rolling the earth around nothingness, which is all that space, all that black stuff, okay, there. And just keeps rolling it around. Why? Because every atom on earth is connected to every atom of the sun. There is a something, something's known as ropes, electromagnetic ropes, and those ropes you cannot see, or you cannot touch, okay? You cannot see or touch the ropes, because if we could see or touch the ropes, which is the hang up it just about everybody has out there who gets shocked by it, we can't see or touch because Mother Nature made them intangible and invisible. Why? Because an object is not that which is tangible or visible, it's that which has shape. That's first. And second, if we could see or touch the rope, we would be tangled in knots, and that's all we would see. We would just see ropes everywhere. Fortunately, we can't see the ropes. Fortunately, we can't touch the ropes, because Mother Nature was smarter than all the people on Earth who are asking for tangibility, proof of tangibility and visibility. That's the problem. The problem is you're asking a stupid question when you ask to touch the rope through an experiment or to see the rope. You will not see it. You got to visualize it so that you can imagine the mechanism. You got to figure out the mechanism that Mother Nature is trying to figure out here, is how, what she uses. That's what you're trying to figure out. Okay. Here we have an interesting point that he tried to make. Okay, and that's Einstein said that the man feels no force pulling on him because there is no force pulling on him. In other words, when the man falls from with an elevator, okay, he doesn't feel his own weight. He's just floating in space like an astronaut would. That's the principle of equivalence of Einstein, right? Gravity doesn't act on him. It acts on the space and time around him. That's what Einstein discovered, or so he did, right? What we now call geometry of space-time. We have to think of gravity as the shape. We have to think of gravity as the shape of space-time changing. Okay, Einstein said that space and time aren't fixed and immutable. They're interconnected, meshed together in what is known as space-time. Space-time can be warped, and matter curves space and time around it. How does matter curve time? Time is not a physical object. Time is a concept. Does matter also curve love and intelligence and grace and anger and all these other concepts that we invented? Does it curve everything? How can it curve time? How can it curve energy? How can it curve mass if all these are concepts? How do you curve a concept? But the interesting thing is how he labeled or how he illustrates these things, or how all these mathematicians illustrate these things. Why don't they illustrate it like this? This is what we would like to see. Why don't they curve it upwards so that people start asking questions? Say, oh, hold it. How does mass push upwards? See, they always have mass pushing the thing downwards. They put a ball in there, ball on canvas. Why does the ball push upwards on the canvas? Well, because if they put it like I do on the right, maybe people start asking questions, say, well, hold it. How does mass push upwards? See, we're always used to mass being pulled downwards by gravity. And if you put this as a picture, people would start asking a lot of questions. So they never illustrate it like that. They always illustrate it with the concave part downwards, okay? So that's cheating. They should at least once in a while, so to wake people up so that people understand what's going on there. Why does it push upwards, the canvas upwards? And what pushes mass downwards? What pulls on it downwards? Gravity? Yeah, they explain gravity with gravity. That's how they do it. Okay, and here you have similar or a contextual, same context there. It says, body like the Earth warps the structure of space and time around it. And so they have this satellite. This is from NASA, by the way. Okay, NASA has a little satellite moving around our space. And the only issue we like to ask is, what is that black stuff that holds all those stars out there? What is that? I mean, if this is space and time, the fishnet, what is the black stuff? That gives shape or contrast to the fishnet, to the canvas, to this trampoline that they've got there. But he says, and an object in orbit follows a path which is as straight as possible through space-time. Straight? That looks like it's going in a curve. It's curvilinear type of orbit, because the moon is not going straight. The moon is going around in circles. How do you call a circle straight? The edge of a circle, that would be a tangent, to the circle. And then you can talk about straightness. But aside from that, we got the issue that he's not talking about straight. He's talking about rectilinear, because he's talking about motion. Straight is a line. Itinerary is rectilinear, and he's talking about rectilinear itinerary, okay? But he says as straight as possible through that space-time. How can it move in straight lines when I see it going in circles around the depression there, okay, created by the Earth? So he says, so matter warps time as well as space. How does matter warp time? My God. It's known as gravitational time dilation, which we just covered. And it's possibly the strangest of all of Einstein's discovery. No kidding. Time is being distorted. It's got to be the weirdest thing you ever imagined. Yeah. If time is being distorted by matter, we've got a serious mental problem in all of mathematical physics, in all of mathematics, because all these people are just mathematicians. Okay. He continues here. He says, this telescope proved that Einstein was in fact right. All the mathematicians are right. They're correct. They're true. They're never false. Okay? That gravity does curve space itself. How can you curve space if space is nothing? Didn't he talk about empty space? What does he mean by empty space? If we empty space of all matter, what do we have left? Nothing. But then they say nothing is made of something, of little particles that are called virtual particles. Two particles, we covered that last week. Two particles, a negative and a positive particle make a no particle, or a no ball. Or you have a black ball and a white ball and they make a no ball. When you separate them, you have a white ball and a black ball. Great. I mean, anybody can do that kind of magic. So he says, this telescope proved that Einstein was in fact right, that gravity does curve space itself. Since then, observation after observation have confirmed that matter curves space and slows down time. Now, how's that for religion? Okay. Old time religion. Okay, and then he just mentions that LIGO, they got the Nobel Prize in 2015 for detecting gravity waves that travel at the speed of light and not 1 second faster. Okay, and they have this big apparatus. They had to do something. They were investigating and investing in LIGO for 50 years. They had better come up with something. They say, "You guys better come up with something. We'll just give you a Nobel Prize and make you famous." That's what they did. No truth, no value to LIGO whatsoever. It's just a waste of money and time. Okay, so after all that, after he talking about 2 hours on gravity, what does good old Al-Khalili conclude? And this is the funny part, because he starts out saying, even today, understanding the true nature of gravity remains one of the biggest challenges in science, meaning they have no clue. Okay, let's get that right up front. He's saying, biggest challenges in science. They don't know what gravity is. We're still investigating. We're still running experiments. And the only experiments they needed to do was the one I did with a rock. Here, I'll do it with my comb. Okay, let it go. There, that's the only experiment you ever needed to do. Now you got to explain how Mother Nature does that experiment. And they just keep doing experiments and say, oh, we're going to do more experiments. Another LIGO, another big experiment, billion-dollar experiment. What do they need experiments for? They need to explain gravity. We're done. And it's got to be the simplest thing on earth. All you got to do is visualize the invisible. Once you do that, you're done. You got to tell me what came in contact with the rock that I let go of. Something had better come in physical contact with a rock, because otherwise you're putting spirits, ghosts, in that same space. You're saying it's done by magic. No, it's done by magic only because you can't see or touch, which is what we're used to in our everyday life. And we touch and see things, and so we're used to that. And suddenly someone says, look, something came in contact with a rock or with a pen or whatever you let go of, with the skin of the rock to bring it down. When the guy said, well, I can't see or touch anything, well, that's because this is not a question of seeing and touching. It's a question of visualizing. There better be something there that Mother Nature uses. Otherwise, you're filling that same space with black magic. Until you understand that, you haven't understood anything in rational science. I've come to an extraordinary conclusion. The different ways that time flows may not be some quirky byproduct of gravity. It may actually be gravity. Time is gravity. It may be the cause of gravity, the reason why objects fall. Time is the reason, the cause, the mechanism of why objects fall. Now, how's that for a theory? So my investigation deep into the weird ways of gravity has finally left me face to face with one of the greatest mysteries in all of physics, the nature of time itself. Yeah, if you don't define time, you don't know what you're talking about, then it's going to be hard. You're going to have trouble with the nature of time if you never define the word. Why does the apple fall? The apple falls because it's seeking out the place where time runs the slowest. After studying 10 years at the university, after going through this holy grail, of trying to find out what gravity is, that's what good old Al-Khalili comes up with. He says, time is not money, time is gravity, okay? Or maybe it's both, I don't know. And again, here are my conclusions. Let me put this over here. This guy is a caricature of a physicist. He's not a physicist. I don't care how many years he studied at the monastery. He has no clue what physics is about. Physics is not about experiments. Physics is not about mathematics. It's not about measuring. It's not about running experiments or calculations or equations or making predictions. None of that has anything to do with science. That's the old scientific method that died with the rational scientific method that came into being at the beginning of this century, really 2 years earlier, 1998. And so here I go again. He states that gravity is central to his line of work. He's Suggests he's an expert, that's what he does for a living. He can't define mass. He talks about an idiotic thing known as time dilation, which can easily be debunked with two hourglasses. You put one like I did at the top of the the Eiffel Tower, and one at the bottom, okay? And you'll see that the one on the bottom goes faster, not slower as Einstein predicted, okay? Gravitational time dilation debunked it can be debunked with two hourglasses. Doesn't understand the difference between describe and explain. He claims without justification that there is no object binding the earth to the sun. Yes, there is. It's known as the rope. A bunch of ropes, and actually, every atom in the earth is connected, physically connected to every atom of the sun. Otherwise, you're doing this with magic. You got to explain the mechanism why the earth doesn't fly out of the solar system. What are you going to say? What this guy says, that it's warp time, is that time comes in contact with the skin of the earth, and that's what prevents the earth from flying out. Makes a rational proposal that matter warps time. Absolutely idiotic. Okay, no such thing as time, so you can't warp it. It's not a banana. It's not a hammock. You can't bend time like you bend a hammock. And if you can't dismiss and just say, well, I was just kidding. It was just an analogy. No, I need a physical mechanism for why the Earth doesn't fly out of the solar system. Don't tell me later, after 2 hours of telling me it was warp time, that, oh, I was just kidding. No way. Asserts that a telescope proved matter warps space. How a telescope proved that? That space is nothing and you warp nothing. How did you warp nothing? Okay, and he says that time is what gravity is. Gravity is time. Time is gravity. Time is not money. Okay, folks. With that, I'll see you next time around, Wednesday. And I might continue with Al-Khalili because he's got a lot of material out there. So this guy needs to be put in his rightful place. And his rightful place is a caricature of physics. We'll see you then. Bye-bye.